All right, class, welcome back. Want to deal with this major topic, which I'm going to call carbohydrates. As you're aware, just like proteins, carbohydrates are part of the diet, part of the balanced diet. So I mentioned you need what? Proteins, carbohydrates, fats, vitamins, isn't it? You can add probably other small things, but those are the major things, yeah. So what you're going to realize is that carbohydrates may just appear to be like a name which came from it may appear like a layman's name, like probably proteins, but you're going to see that the name carbohydrate is actually a chemical name. Yeah, carbohydrate is a chemical name, and it's made up of carbo. Carbo is a short for carbon, and then hydrate is water. Can you see? It's not just a common name. So it's a common name, and you're going to say, for example, I've just taken. Okay, let me say that there are two major classes of carbohydrates. You're talking about like in chemical terms. There are those which are made up of an aldehyde, and there are those which are made up of a ketone. A ketone and an aldehyde have got a carbonyl group, a carbon-oxygen double bond. So in this case, an aldehyde has got a hydrogen next to the carbonyl group, as opposed to a ketone has got two carbon atoms next to a carbonyl group. Now in this case, I've just taken one which has got four carbon atoms. What you're going to see is that you're going to see this structure being repeated. There is a carbonyl group, and then after that one there are carbon with a hydroxide group attached to each. Each of the carbon has got a hydroxide group until you exhaust all the carbon atoms. But in general, yeah, the smallest carbohydrate has got 3 carbon atoms up to like 6 carbon atoms. So we'll be dealing with 3, 4, 5, and 6 carbon atoms. Yeah. So whether you're dealing with the one dealing with the aldehyde or the one dealing with the ketone, they start from 3 carbon atoms to the 6 carbon atoms. So for the different varieties, and they've got different names, you'll refer to your notes. I will not be able to give all those different structures and their names. Yeah. So like, let's look at this structure. It's got an aldehyde, and it's got 1, 2, 3, 4 carbon atoms. The one for the ketone has got 1, 2, 3, and 4 carbon atoms. So if you have to look at the one for the aldehyde has got how many? 1, 2, 3, 4 carbon atoms. Hydrogens are 1, 2, 3, 4, 5, 7 plus 1, 8. Yeah, and then oxygen are 1, 2, 3, 4. So it is C4H8O4, and this one can be put in bracket C4, and then this C8O4 can be put in bracket H2O in bracket 4. Yeah, and the same thing like the one for the ketone, it can be shown it is 1, 2, 3, 4, 4 carbon atoms, 8 hydrogen atoms, and then 4 oxygen atoms. Yeah, so in bracket is also the same formula, C4H8O4. As I mentioned, the simplest carbohydrate has got 3 carbon atoms. The biggest one has got 6 carbon atoms. So you can see this structure can be put in bracket, can be put in general terms as CnH2O in bracket N. That if you know the number of if you know the N, for example, like 3 or 4 or maybe 5. If you're talking about 5 carbon atoms, then there are going to be 5 water molecules associated with the carbon atoms. So that's why the name carbo for carbon, and then hydrate for water. Yeah. So carbohydrate is a chemical name. It's not just a layman's name. It is a chemical name showing that you've got carbon and then water molecules associated with the equivalent number of carbon atoms. Now, there is a common name for the carbohydrates, and they are given the name saccharides, not the capital C, for the saccharide meaning sugar. Now you need to distinguish the sugar from the common sugar that you know, like the one which you probably, if you like to sweeten your tea or coffee, the one which you added. Yeah, that one is normally given the name of sucrose. Yeah, sucrose is the table sugar. What you're going to see is that is not the simplest sugar. What you're going to see is that there are much more simpler sugars like glucose and another one called fructose. Yeah, yeah. So those are simple sugars. I just want to give an analogy of something like salt. There's something which you call table salt. Yeah, which is sodium chloride, but there are many compounds which can be called salts. Yeah, that a salt is the neutralization product that is formed when you're going to mix an acid and a base together. Yeah, like if you're going to have what, sodium hydroxide as the base and then hydrochloric acid, so you're going to get what, sodium chloride and water. But you're going to see that potassium chloride and there are other salts which are not table salts. Yeah. So in this case, you're going to see that there are many types of saccharides which are not sucrose, as it's called. So let's get to the different classifications for the saccharides. Monosaccharide, it means that it has one sugar unit. Yeah. Or is okay, you can say that it's got, I think that's the word you can use. One sugar unit, one saccharide unit. Disaccharide, it means that you've got two sugar units which are joined together by something which you're going to call a glycosidic bond. Yeah, but you're going to see that one. And then if you're going to have up to 9 sugar units, saccharide units joined together, then you're going to have the name of oligosaccharide. And then beyond there, then the name changes to a polysaccharide. Now, in a way, this is similar to the classifications that we had on the proteins. We are saying that the simplest one are amino acids. They are joined together by a peptide bond to form peptides, and then you've got small peptides, probably up to what? Even something like 50 peptide bonds can even be called. It's still not called a protein. A protein is quite large. For example, you're going to see that a peptide like what? Like insulin, yeah? It's got probably around 50 peptide bonds, but still called polypeptide, yeah? As opposed to being a protein. So you have monosaccharide, disaccharide, oligosaccharide, and polysaccharide. Now let's get to the classifications of the single sugar unit, which I'm going to call monosaccharide. It can be further classified by the number of carbon atoms attached to which make up the monosaccharide. If it if the monosaccharide or the sugar unit has got 3 carbon atoms, then you're going to use the name triose, 4 carbon atoms tetrose, 5 carbon atoms pentose, 6 carbon atoms hexose. And then so it means that like the one which I'm showing on the left and this one on the right, like in this case they have got what? They have got 4 carbon atoms. But the main difference between this and this one's comes from the fact that this one contains the ketone and this one contains the aldehyde. So this is now where the next classification comes in. If the monosaccharide has got an aldehyde, it's going to be called an aldose. It's going to be called an aldose. And if it's got a ketone, like in this case a carbonyl group with 2 carbon atoms, it will be called a ketose. Okay? So, based on this definition, based on, not definition but classification, how can we classify these 2 compounds? Now, it has what? Usually the name of the functional group usually, excuse me, usually comes first. So in this case, this one is going to be called an aldose. And then it has 1, 2, 3, 4. So it has 4 carbon atoms. So it will be called an aldose tetrose. Aldose tetrose. Then this one it will be called a ketose tetrose. Ketose means that it has a ketone group and then it has 4 carbon atoms. Yeah. Now I think I'm going to delete what we have on the board. And then we proceed on to the next. So there are 2 major monosaccharides, one an aldose and the other one a ketose that are well known. So I'm going to put okay, like one, 2, 3, 4, 5. So I'm going to put now 1, 2. And then the let me put a hydrogen. Now so there is that one, and then the other one is 1, 2, 3, 4, 5. Okay. All right. So this one you're going to call glucose, and this one you're going to call fructose. Yeah. All right. Now, even though I've drawn these structures like this, there's a way in which they exist in 3-dimension, and in something which you're going to use the word, there's something called a Fisher projection. Yeah. It's a way of showing molecules like in 3 dimensions. So, but in our case, because we are just dealing with this course within a very short time, we're not going to go to something which we're going to call stereochemistry. But this presentation is just a simplistic representation of these molecules. And also something which you're also going to see is that is that these structures, even though they have drawn them in linear form, they can also exist in a cyclic manner, in that they can actually form like this one, like the glucose, it can form a forms a 6-membered ring. As opposed to the one for the fructose is going to form a 5-membered ring. Yeah. So I think like this one for the glucose. Let me just try to see how I can just try to draw it in a. In this case, it will be. Okay, in this case, okay, let me avoid going into all those chemical terminologies, because chemical reactions, because once again they require a lot of background on reactions mechanisms and also stoichiochemistry. But we need all what I need to mention is that this structure is going to be, this structure is linear, but it can exist in a ring, and similarly the one for the fructose, they can exist in a ring. And what I need to mention is that assuming you've got one monosaccharide unit, and then excuse me, there is an OH, and then there is another hydroxide group to the second monosaccharide unit. So this is monosaccharide 1. This let me say MS1, MS2, monosaccharide 1 and monosaccharide 2. So they can come together to form an ether bond. Oh, so in this case, the one in the middle is not just a cyclic structure. It's just, that's an oxygen. So that's an ether bond. So that ether bond is given the name of glycosidic bond. Okay, that one is called a glycosidic bond. Okay, so so with that, I think you may be able to look at your notes. For example, you're going to see that there are certain monosaccharides. If they come together, then they are going to form certain disaccharides, which you well know. For example, if I'm going to say glucose, and then another glucose, if they are going to be joined together through a glycosidic bond, then they are going to form what? I want to see that one. It's going to form a disaccharide called maltose. Okay, but then let's go to the one which you well know. If you've got a glucose, and then I join with fructose, then you're going to form what? You're going to form sucrose. And then lastly, there is another one called what? Glucose, and another one called. So that will lead to the disaccharide called what? Okay. So this is telling you that maltose, sucrose, and lactose, these are what? These are disaccharides. Disaccharides are made up of two monosaccharide units. Okay. Yeah. So this tells you that before if you're going to take something like sucrose, before it is taken into the bloodstream, it needs to be broken down into into the monosaccharides before it's absorbed. In this case, it needs to be broken into glucose and then glucose and fructose. So the thing is, if you're an athlete and you really need instant amount of, the sugar to be absorbed into your bloodstream, then you should not take table sugar. You should take something like what? Like glucose. Glucose is a monosaccharide. It's going to be absorbed immediately into the body. Right. So there's something I need to mention, and and this relates to the polysaccharides. Once again, I'm just passing through the notes so that I'm just focusing on some things that may just require clarification, but I believe the notes are self-explanatory. If they are not, then I think you can get to me to say that maybe there's something that may need to be expounded regarding a certain amount of notes, certain notes. Now, glucose is the most widely available monosaccharide in nature, and a lot of compounds, they contain glucose in a repeating form. So you're going to get two major types of compounds, of polysaccharides, if I may use, that contain glucose as the repeating unit. Now the main difference comes from how one monosaccharide, one glucose unit is joined to another one. Let me say, if I've got a sugar unit like this one, I'm just trying to put it in a simplistic manner, but if you're going to look at it in a ring, there are some oxygen atoms that are either facing horizontal. It means that they are said to be equatorial, and there are some which are going to be axial. But if you're going to have one glucose unit and it's going to be joined with an oxygen to another oxygen unit, and no, glucose unit along the horizontal axis, in this case, these ones are joined in a linear manner. Then the repeating unit is going to be called cellulose. But if you're going to have one glucose unit, you've got an oxygen, and then it's going to be joined in a vertical manner, something like that one. So this is a glucose unit, a glucose unit, a glucose unit. It's like it's in a cyclic manner. Structures can exist either in a linear manner or in a cyclic manner, but still the same structure. But once again, we'll not touch that one into mechanism. But just to know that one, but looking at the note, there is the mechanism of how a linear structure can cyclize to form a cyclic structure. Now, if it's going to be joined like in an axial manner, in this case, the glycosidic bond between one glucose unit to the next one is via vertical bond. Then the polysaccharide that will be formed, it will be given the name of starch. What are we saying? Starch and cellulose, they are polysaccharides, and they're just made up of only one repeating unit called glucose, being joined together via glycosidic bonds. Now, depending on how one glycosydic body, one glucose unit is joined to the other one, that will make a difference between cellulose and starch. Okay. Now you'd ask yourself, does that matter? Yes, it matters because, as you may remember in the last video, or I think it's video 3 regarding regarding proteins, I mentioned there are these biological catalysts, proteins. They are called enzymes. Enzymes, they have this tertiary structure of the protein. Now, they usually have a specific pocket in which the molecule to be catalyzed has to fit exactly on that pocket for the catalysis to occur. So in this case, what I'm going to say is this: if you're going to have a pocket which is probably facing zigzag, going down, it means that only a starch molecule can fit onto that pocket, as opposed to if the pocket was probably linear, then a cellulose can be able to fit that up. So in other words, we are saying that the enzymes can distinguish between these two polysaccharides. So the ones which we have in the body, like what, human beings and others, like what, most of the mammals. I'm trying to avoid the cattle. I'm talking about the goats, the camels, the ones which are called ruminants. I'm just trying to avoid those ones. The others, they can only digest starch. You and meat, it means that, okay, before I get to that one, starch is the main component of something like what, potatoes and the rest, yeah? As opposed to grass and pepper and the rest, they contain what, cellulose. So the enzymes that you have in your body has got the receptor pockets which can only in which starch can only fit onto the pocket to be able to be broken down, as opposed to cellulose, because of its linear nature, it still contains glucose, but it cannot fit onto the pockets for what? So in other words, you're saying cellulose cannot be broken down by the enzymes that we have in the body. So it means that you can be able to take grass, as sort of to say, you've been hearing this thing of people. Sometimes they go mad. They do what? They go to the field and they start eating grass. But technically speaking, your body is not meant to digest the grass. I don't know what happens to the grass once they take, unless of course you are if you like the Bible studies, unless of course you are Nebuchadnezzar. I don't know whether he was given the enzymes to be able to digest the grass. The king of Babylon, yeah, he's called Nebuchadnezzar. He was, for about probably 7 seasons, I don't know whether there were 7 years or whatever, he was able to eat the grass like with the animals. But you and me, if we're going to take grass, it will not be digested, because your body is meant to do what? To digest starch. Yeah. So cellulose. So cellulose is broken down by some other mechanism, which I think, though we are going to mention it mostly in the aerobic and anaerobic digestion, but cellulose is broken down by bacteria and should I mention that one before the anaerobic and aerobic digestion? But the thing is, through anaerobic bacteria, the aerobic and the anaerobic bacteria that are found in nature, and they've got something called a rumen stomach. Yeah? So through that compartment which does not have oxygen, the bacteria, the anaerobic bacteria, uh, once the animals like the cow and the goats, they take in the grass, the bacteria which they pick from the system, it goes into that rumen stomach, and they're the ones which break down the cellulose into methane and carbon dioxide. Yeah, but that one you're going to do to look at it mostly under aerobic and anaerobic digestion, which is the last lecture we are going to look at it in the series. But as for you and me, unless if unless and I don't know whatever situation, but you're not good, you're not you do not have the anything which can digest the cellulose. So your body is only meant to digest the starch. I don't know whether there is anything I've left regarding regarding that one. So you're going to look at the rest of the notes, and they are going. I believe they are going to make sense. So what have we said? Carbohydrates. In the simplistic form, they contain monosaccharides, and the monosaccharides have got either an aldehyde group or a ketone. If it has an aldehyde, it will be called an aldose. If it has a ketone, it will be called a ketose. And then, depending on the monosaccharide, the number of carbon atoms, it will either be called triose, tetrose, pentose, and hexose, and the rest. Yeah. And then the monosaccharides, they are joined together through a glycosidic bond. It's like an ether bond, but it's called by the common name of glycosidic bond. Just as a carboxylic acid plus an amine, they come together. They're going to form a bond which is called an amide bond, but it's known by the common name of a peptide bond. Yeah, a peptide and an amide bond are the same. Yeah. So and we also say that that the most common sugar which you take, the table sugar sucrose, is made up of two monosaccharides, which is glucose and fructose. Both contain 6 carbon atoms. Yeah, and then a carbohydrate like the one showing 6 carbon atoms, it can also exist like in a ring, like in a 6-membered ring for glucose, or a 5-membered ring for fructose, and depending on how they can join, one cyclic structure to the other one. If they're going to be joining in a cyclic manner, then if it is glucose, then the structure which will result will be called cellulose. But if it's through something called axial bond, then it will be forming starch. So I think you'll be able to look at the bonds, I mean the notes, and they're going to make sense. So let's stop there regarding carbohydrates, and then we'll continue looking at other topics shortly. Thank you very much for listening. Okay.